So I was part of Group 1, Shared Streams, Collaborative Approaches to Water Scarcity. And our leader of our group is originally from the Netherlands, which you guys might know is kind of a wet country. So they have a lot of rain there, a lot more than we do here. But we discussed how even in the Netherlands, water scarcity is becoming an issue. So drought is not something that is just confined to desert locations. It's something that communities all around the world are starting to experience, and everybody needs to be preparing now for it. So we had a lot of different conversations about different things that can impact our water management, and discussed how One Water includes water analytics, so the data that we know about our water systems, water governance, how we collectively decide to manage that, and the actual water management. We discussed how timely data can enable timely responses. So if we know where there are leaks, when the leaks happen, not a month later when we get our bill, we can do a much better job of addressing those as they're happening. We discussed proactive insights, so taking a look at how old our systems are, how old the houses in a neighborhood are, what the materials are made out of, and being a little bit more proactive rather than reactive. We also discussed the value of enterprise-wide views on data analytics and making sure that we don't have silos in different parts of the organization, but that everybody has access to all of the data available. And we discussed that climate forecasts don't always exactly agree with each other, and they don't always consider all of the factors that could impact water availability in the future. So these forecasts are important, but we need to make sure that we're considering them in our local context, considering other factors that could influence our ability to deliver water. And we discussed how small utilities often don't have the resources or the depth of data available to them to make the same decisions that large utilities make. So by sharing resources, sharing knowledge between the different utilities, we can create better systems for everybody. And I can pass it on. I can keep going.
All right, so that was our report out from Table 1. Anyone from Table 1 feel like they want to add one more thing? One more thing, one more conversation, one more, this was the thing that really is going to go home with me today?
I would add to this that there's a big appetite for sharing. Whether it's among smaller municipalities. We have an example where the city of Singapore is far away. What can we learn from each other? The scale of the city of Phoenix, the city of Singapore. There's best practices all over the world, and let's bring those best practices together so we can all advance and improve. I think that was a great takeaway.
Yeah. And I'll actually add one more plug because I saw it down at the bottom, but we also discussed the importance of change management, like the city of Phoenix pointed out at the beginning, because we can start all sorts of amazing initiatives, but if they don't get maintained over the long run, then we're not benefiting from them.
All right, thank you, Table 1. I believe in prime numbers, so to make things confusing, Table 3.
I'm Table 4.
Where's our Table 3 representative? All right. Come on, John.
Here, you want to hold that?
Yeah, I will hold it for you.
Clint promises to not make jokes, but he will Vanna White for you.
There we go. So we started out as the title was on-prem versus cloud, and we kind of went all over the place. Some of the, I guess the big takeaways is that is a feature and a luxury that some of us larger utilities can do, but obviously the smaller utilities don't have the resources to do stuff like that. And can some of the onus of providing some type of technology that could be packaged in that would make it easier on smaller utilities to have that available to them. We kind of morphed into talking about the cybersecurity side of things, and how secure do you feel, and the way the city of Mesa the way we've done our pilot and our model, we feel very confident with it. And it was the big trick was try to get that data to our vendors so that they can help us in designing and engineering the changes we need with the city as the city grows at the rapid rate it's growing. Because they need the data, and it's just housed inside a cocoon inside each plant or in our distribution system. And so by using the Azure cloud in this particular case and using MQTT through our historian, we're able to get that data out there. It's an island, it's a one-way street, basically a data diode, and then it can be basically parsed out as far as what data the vendor should be able to look out at that level and try to streamline some of, we're still going to vet the vendor. They're still going to have to go through, ID checks and stuff like that. We're not waiving any of that, but we are trying to get the data in a better way and fairly fast. I mean, 5 seconds to 15 seconds. So it's pretty close to real time. And that was basically the basis of our topic. And again, then we rolled out into one of the things that, anyway, it's close to my heart from the cybersecurity side, and that is getting the engineering firms on board with including that in the engineering and design, include ICS's security requirements and needs, not just civil, but include that in your civil. And I know that there's firms out there that specifically deal with that, but yeah, I'm not seeing it when it comes across, and I look at a lot of submittals, and none of them really address, access. None of them really address, how the PLCs are put in, where they're put in. It's just like, okay, where's the closest corner? Let's put it in there. So that was one that's close to me. What am I forgetting? I'm trying to think of what else. We went all over the place. That's it. Time's up.
All right, thank you, John.
All right.
Are we going to 5 now? We're sticking to prime members? 5?
Now we can change our methodology. I like to confuse and startle people, so it's. You're just gonna hand it to someone?
Oh, here we
All
go.
right, table 4.
We'll keep going. You just put it right on there, and I'll be your Vanna White. Not nearly as pretty. Oh, I got you. Okay.
All right, so at Table 4, we talked all about scaling wastewater monitoring. There was a pilot study done in cooperation with City of Phoenix and company Candu based in Israel, and they looked at helping to get City of Phoenix to monitor their giant network of sewer collection pipes. Over 200 industrial users in the City of Phoenix collection system, 50 of those being significant industrial users. And how are we going to track what they're putting into the pipes? Well, this company with inline monitoring of the collection pipes can notify City of Phoenix collections operators, pretreatment inspectors, wastewater treatment operators on what's coming into the plant. And that's massive for looking at where areas of concern are, and especially in the future as state of Arizona starts to implement advanced water purification, there's going to be regulatory requirements in the collection system to prevent contaminants that we don't want in the drinking water getting into our wastewater treatment systems. So with that technology, this is a very pilot study, and we talked about how they started using a in-solution monitoring system, and then advanced to an AI system, which was above the water line, using monitoring the fluorescence of the wastewater, and that technology could expand to be for other uses as time goes on. They won that project with the City of Phoenix and looked in how to implement or how to determine what areas of the collection system are important to monitor, but using their heat map to identify areas of concern and what problems are associated with that. And currently they have 17 of these monitors in the system, and they're just looking to expand it even more so they can target more of those significant industrial users and meet those requirements as they get more stringent. And the big takeaway from what we discussed was that it's not so important what or how we measure but that the most important thing is the data that we collect and how we make, what insights we gather from it. So, thank you.
Thank you.
All right, thank you, Table 4. Next up
Excellent.
is Jeff with Table 5.
I'm setting this down. I'll just hold it. There we go.
Yes. Hello, everyone. I'm Jeff. I'm a civil engineer with the tiny agrarian village town of Gilbert. Just a tiny town. So we had water quality monitoring as our discussion, and I kind of let it out as a griping session. So we just kind of let it all out there. So we're going to let you know what we griped about. So under water quality monitoring, it covers a lot of ground, right? It's not just water, drinking water. It's reclaimed. It's wastewater. It covers a lot of turf. But ultimately, a lot of that comes down to regulations, right? So the official monitoring that we're doing out there is under some specific regulations, and that creates a lot of unknowns and uncertainty for all of us in this industry. And so we're always trying to look ahead and see what are those regulations that are going to happen. And we talked about the resolution of the contaminants because, over the years, if you look back, basically, the better that we can sample, like it started out as parts per million, right? We were in parts per million. So now we're addressing like nitrates and things like that. Next thing you know, we're parts per trillion. Oh, hey, now or parts per billion. Hey, now we're doing arsenic. Next thing you know, we're parts per trillion. We're looking at even finer chemicals or contaminants like PFAS and things like that now. So it's the industry and the resolution of data has a lot to do with what we have to do and measure for. Online instrumentation is huge in our industry. I'm pretty certain everyone here who's in this business has some online instrumentation of some sort. We're always looking for something that's more reliable, more affordable, and is it going to be something that helps us with compliance, right? We have to make sure that it has some certifications and some reliability that we can use that data to report to the regulatory agencies. Oh, by the way, everything I just talked about takes resources, right? So not just the money resources, but the stuff behind it, like the workforce, right? You're going to have to send more folks out in the sampling system to take samples out in the distribution, out in the collections to do this. So it's not just I'm throwing dollars at equipment. It's bringing more people in to do this to help us maintain compliance out in the distribution. We talked about the seasonal changes in water quality. So the sources can change, not just the temperature. Like in the valley here, of course, the water temperature can go up over 80 degrees during the summertime, but then easily go back down to below 60 degrees during the wintertime. It has an impact on the chlorine residuals, the trihalomethane disinfection byproducts, but also the source water. We talked about the SRP source water can come from 2 different reservoirs, and those have different water quality, and they may go through the same treatment plant, right? So everyone there has to make changes in how we treat the water too. Compliance versus process operations. So what we're talking about here is that in a regulatory standpoint, we're told that we have to sample on certain intervals and report to the state what we're doing. But in the meantime, we want good water quality and compliant water quality every minute. So our online instruments are being checked constantly, and internal to the water supplier, this is being done. It's even if it's not a specific requirement, we're doing it anyway, right? Because we want to send out the best water quality possible. Okay, this one right here, lab quality control. Who here has gotten different results from 2 different labs, right? Yeah. I'm not even going to say anymore, right? That's all you need to know. You can do whatever you want to. You can pick the one you like, I guess. So liability. The more and more we have regulations, the more and more regulations that come out on different instruments. We're buying these instruments from vendors. And one of the questions came up was like, well, who's liable if it's not doing a good job? These are good questions. Yeah, we don't have the answers to this. Ultimately, it's us as the water provider that is kind of hanging out there, right? So this is a good question. Maybe it needs to be discussed internally, right, about the liability for specific pieces of equipment. Source tracing. Let's say all of a sudden half the bugs died in my wastewater treatment plant. Do you have the equipment? Do you have the understanding of the system to go back and find out where that happened? I'm going to wrap it up quicker. Controlling waste. Obviously, whenever you put an instrument online, it's wasting water to do that test. The emerging contaminants I talked about early, we talked about the polyfluorals, the next phase of PFAS-type compounds, pharmaceuticals, which, gosh, we've been talking about for like 30-something years, been a long time. And then supply chain issues. This is huge when you're buying equipment. I mean, what if the piece of equipment went down and you can't get it for another year and a half, right? Or what about the reagents that you got to put in there if you're running out of reagents? So anyway, that's everything for water quality monitoring. Thank you so much. I appreciate it.
All right, next up, we have table, I don't remember what number, 7.
So we were at table 7 looking at really what the path is from here to autonomy and cyber secure autonomy and deployment of AI systems within the utility sector writ large. And I would say the 2 big places we spent a lot of energy were thinking about what that path looks like and what the likely path looks like toward autonomy across a utility. And so I would say the primary take-home message there was twofold. One is that nobody really believes that somebody's going to turn over the keys to an entire utility system, including all control systems, anytime soon, not certainly to a standalone autonomous decision-making system. That said, there's a real need to be pulling in a lot more automated systems, particularly as we're talking about challenges in staffing wastewater systems, difficulty in finding people who want to take those jobs or have the skills. So some of this is figuring out how we start to fill those gaps, given the constraints that we have and given the utility of the functions or of the technology that we have in hand and that is being developed. The second piece of this is then really looking at how we go about doing that and which systems are within a utility are sort of most primed for starting to deploy ML or AI systems to start meeting those needs. And I would say across the board there were, anytime that we're looking at monitoring and figuring out how we can assess those thresholds or those benchmarks for when there is going to be a problem and then somebody comes in and actually does something about it. That was certainly something that came up over and over, whether you're looking at water quality or whether you're looking at systems thresholds for where there's going to be a problem. There's also, there was a recognized need that especially when we're looking at high consequence systems like this, where people die if we get it wrong. So there's a lot lower threshold for risk tolerance in those sorts of decisions, so making sure that we have multiple layers and backup systems, including humans in the loop, where we can actually have somebody at the end of the day who's making that final decision. There's also a lot of conversation, by the way, about things like union rules and what it actually means to have a licensed operator operating a utility. What is that threshold? What is the legal threshold? So there's some real questions there that came up at the table around how we even parse those regulations in the context of these new tools. I would say the primary take-home messages were that we do have real drivers for needing to figure out how to implement these systems and then figuring out how we best do that. So that's about then walking in and saying, okay, what is the AI tool specifically? It's not just, here's my utility, take off and run, but it's in this specific domain, there's a really high resolution tool that can be deployed. How can it be done? Do we have the right data to feed those systems in that context? If you're working in Santa Margarita and we aren't even collecting automated data from, say, the meters, well then it's very hard to automate that system, certainly with an AI tool. On the flip side, if we're talking about cybersecurity monitoring or systems in water quality where we're already capturing a lot of data and have the mechanism to employ feedback loops, that's a really good target for initial applications of these systems. So what else do you have to add? What did I miss? Looking at my table, it was a great conversation. Thanks.
Thank you.
Awesome.
We got Fair Yeager representing table 6, if memory serves.
I left my report
reporter outer to a phone call, so I'm stuck. But for intelligent O&M topic, we talked a lot about the inputs and data that you might have or not have related to using data and information to help optimize your facilities or other features within your utility. So even if you have data gaps or don't have a single source of truth, you could leverage spreadsheets that operator records are kept within, or leverage sensors, like was already mentioned. Or you might have data overload, right? And your operators don't have the ability to ingest all of that information themselves, even within a dashboard environment, to be able to make educated decisions to help optimize facilities. So that's where you can leverage data science and machine learning to help optimize. And we were talking about low-hanging fruit, like using AI to search your O&M manuals so that your technicians and your maintenance staff or electricians can actually find the information they need at their fingertips without filtering through dozens and dozens of records for RAS Pump 6. Also, being able to leverage the institutional knowledge that your staff have and being able to validate the knowledge that they have by saying, okay, well, this is what we're recommending that you implement for optimizing your facility. Does that make sense? And making sure that the operators maintain control where they're able to actually make the decision. The AI or the tool, like you mentioned from Table 6, is not doing it for you. You have that human intervention to confirm that this makes sense. So that's the short wrap up. Thank you.
Thank you. Just want to take a moment and say thanks to everyone who presented out. That's not easy. We have one left. For those that are kind of hovering in the back of the room, if you, just so we can keep on schedule, if you can kind of find your way back to your seats while we get this one going.
Okay, I'll be quick. There's no need to hold this one up because nobody can read my chicken scratch. I doubt even a good AI tool could read the chicken scratch, so only I can. So, but our topic was intuition versus innovation, when is the right time to use an AI tool. And so we kicked off the conversation by just querying the group as to what tools they currently use within their organization that they would classify as an AI tool. And it was interesting, we came up with a couple different groups. The most common was the sort of general purpose large language model like ChatGPT or Cloud or something like that. A lot of people are using those just as, I would call it almost as a virtual assistant. That's sort of my primary use case for AI tools out there today. Next on the list was in sort of product support or customer service category. It seemed like we had at least 3 different people who said that they're using AI tools for that service. And then also sort of at about the same level was I would call pipe insight tools. So tools that are being used to get insight into what the condition of the pipe is, or maybe when you might do an operational or maintenance activity on a pipe. So those were pretty common. Less common though was we only had 1 tag on pressure management optimization, somebody using AI tools to manage the pressure in their system, and only 1 on what I would call software scripting or software support. There's a ton of tools out there today that help software programmers generate code and debug code, and I was sort of surprised that only 1 person in the group brought that up as a use case where it's quite common in the software industry. After that, we sort of got into the meat of the conversation and started talking about where people were comfortable using AI tools, and I'd say the summary there was the second that human health and safety becomes involved, or the second that you're choosing to make a physical change to your system, that's where AI is no longer allowed to make the decision, and there has to be a human in the process. For most other use cases, though, everybody seemed pretty comfortable. If you're going to choose maybe where to deploy a maintenance team, if you're going to choose to, or use AI to maybe help make a choice as to where to make a capital investment, everybody was pretty comfortable with those. But the second it came to, if you're going to use it to operate a valve or change a pump operation or change a water quality treatment process, that was a hard no. Everybody said that's when humans need to intervene, and that's where the human needs to make the choice. A couple of side notes as we were talking. Context is super important. I think this was more on the vendor side of the conversation. When you are training these models, having the context and having enough supporting information to properly train the tool so it knows how to make decisions is super important. And then somebody also brought up the comment too, I think this applies a lot to the large language models, is that those large language models are trained on sort of the broad, history that we've got on the internet and all the information that's out there. And they've become pretty good salespeople. So even if it's wrong, it will try to convince you it's right. And so you have to be careful, because it'll sort of give a very good argument as to why it thinks it's right, even if it is completely wrong. So they've turned into pretty good salespeople, apparently. And then last but not least, we talked about sort of the regulatory environment around server farms that support these large language models and AI tools. The environmental footprint for these server farms is growing at an increasing rate. And I think especially in the water and wastewater utility industry, these are things that we need to keep our eyes on, because you're going to have companies like Microsoft and Amazon cutting deals with the state to come and have very large server farms installed in your utility area. And this is going to put stress on your local environment. It's going to put stress on your utility. And if you're not working closely with the state, before you know it, you might end up with a server farm that is drawing off your utility and putting water back into the sewer system as well. So there was a lot of discussion sort of around the pros and cons of this, and when maybe it might be appropriate for the EPA to step in and start to regulate that. So it was a good conversation. Group 2, did I miss anything? Okay, thank you.
All right, thank you to everyone that reported out. We're going to get ready for our next panel, to quote Bon Jovi. Well, we're halfway there.